Meeting is being recorded.
Yeah, I hear somebody's background noise here. We got a mute thing going on. Yeah, so Coffee Compiler Club. Here today to talk about compilers and language runtimes and anything and everything to do with implementing a language. Um, I don't have any, normally I don't have a set agenda. I do have I have a half set agenda today. And otherwise we're recording, we show up on YouTube and in a couple hours. Um, People can ask questions and we steer the conversation where it wants to go. So that's the end of the initial spiel. Um, I've been in conversation with a fellow in Ukraine doing compilers at the wee hours of the morning between air raid sirens. And he was trying to figure out how lattices and type theory things work. And I was proposing to talk about that. You know what? Did I don't see Theodore. Did the doc get updated? That is the usual question. It did. So Theodore's around. He's just not joined us yet. Oh, that's interesting. Um, yeah, does anyone want to start like from leftovers from last week? We had an active conversation going, maybe with David. You were talking about something? Oh, and here's Theodore even now.
Well, I was thinking about talking about how much of a language could you do without generics? Because I was wondering if I can do my language without any kind of templates and without generics.
Well, I mean, all things written before somewhere around the 2000s went without generics. So a large hotspot VM with five or six garbage collectors and two or three compilers and every other kind of language semantic issue on the planet ran without generics, was built without generics using C++ and essentially no templates. So you don't have to have generics. Yeah, it's
You
void
know,
star polymorphism.
see, I know for sure I need it like some kind of I need a containers for like data algorithms like hash maps, vectors.
Yeah,
I forget if there's a better name than ring buffers, but those two.
queues and shit.
Um,
Yeah, Hotspot's full of hash tables that have no generics.
yeah,
Yeah,
so
you
I think
just
have to have a built-in language supports for those.
You
And like I think I
don't.
might be
That's what I'm
able
saying.
to.
You do not have to have language support. It's convenient, but you do not have to have it.
Well, then if without language supports and without generics, you're gonna have to do an implementation for every version of like if like an array for this type, array for that type. You gotta implement it.
No, no. No, for arrays of primitives, you have to do an implementation specific for every primitive the hardware supports. Anyhow, that has nothing to do with generics. As soon as you have pointers to fancy things left and right, you have just the hardware primitive of a pointer, so an array of pointers, and then you use casting. So void star polymorphism means you just cast the damn value.
Okay,
Yeah, I
yeah.
think.
So I meant like while being relatively safe, like Java and C sharp. But
No, no, then you need generics.
yeah,
Yeah, if
I'm
you want to be
still trying to
safe, you got to be generics.
I'm
If you
still
don't
trying
care
to find
about
out
that,
if I can rewrite. Like I want to redesign my language, but I think I have to have unsafe so it can inline into code. And I really would like
wait.
to avoid generics and templates, but
But what
I'm
is what
sure it's going to bite me
what
in the
does
butt
inlining
someday.
have to do with generics? Those are like unrelated topics.
No, no, no. Yeah, they're unrelated. No, I was just thinking because my language, I used to have LLVM generate IR and then just merge the IR to do inlining, but I really don't like LLVM at all. So I want to have a way to do inline with like unsafe code into
Yeah.
whatever function you're implementing. So
No, that's
I,
fine. I mean, C2
yeah,
does that all the time. There's not no
yeah. So
no.
I'm gonna have to redesign my language.
Okay, fine.
But that's like something I'm not going to implement for a long, long time because I don't think I'm going to touch compilers for a while.
As soon as you say generics, you got to do a bunch of type theory stuff too.
Yeah, I'm still like in the middle of Bolt, so I gotta finish that.
Yeah, that's fine.
And I did like a lot of IO related stuff, and because you can't do async open on Windows and Mac doesn't let you do async open. So yeah, I just finished some like IO stuff last week, but yeah. that's a different
Somebody
story.
does an async open thing because the VM has its support for it in all these different platforms.
I if you might be able to do an open like synchronously and then async everything else like the reads, but I think open and close are not async. Linux can do it with
Maybe.
IOU ring, but I don't know of any solution on any OS that's not IOU ring on Linux.
Maybe. All right. For open, you're saying for open and close specifically. Maybe.
Yeah.
Yeah. I'm trying to think through the classic file system handling from Java certainly is synchronous. The NIO stuff has a lot of asynchronous behaviors, but if you ask for an open, there is a wait on a port kind of things. That's different. That heads toward your U-ring solution.
Yeah, my solution is just have a IO thread, and then if I have to do open, I do it there. But
Yeah.
it's okay.
Yeah, that's fine. Okay, what else? Or I'm going to dive into a lecture
I wanted to talk, I
for
mean,
my one Ukrainian re watcher.
I did want to respond just a little bit in terms of generics implementation. I think the way I see it, Levo, is there's basically two approaches to the implementation. And if you want to avoid templates, that pretty much just leaves one. If you have generic functions, and assuming you want to avoid, rewriting things a million times, certainly you can have templates where you're duplicating the implementation. But like much more common in the grand scheme of languages is some sort of, runtime generics. And, you can still statically check them, but you have to have some sort of uniform value representation. Like either you're specializing your function on many different data representations, or you have to have something like, java.lang.object or like some sort of top type that everything can actually belong to, that you like downcast into specific types. And that's not necessarily a bad approach, but it does sort of limit your performance a little bit because it's very hard to beat, you know, pure monomorphization on exactly what your input type is if you want to do like, more sophisticated low level optimizations. But you could still do that as an optimization. I think it's quite reasonable to have some sort of uniform value representation. So I think that's probably like the approach you want to look into. Something like void pointer, but with some type checking. One thing I wanted to say in regards to that is I think my favorite model of this recently is instead of having basically like pointers being your uniform value representation, where you have like void star or something, that obviously has a little bit of limitation because that means you have to actually point somewhere in memory. And if you want to just specialize some algorithm on ints or something, that can be a bit of a pain. My current favorite approach is actually to basically pass these things around as pointer pairs. That still usually means that you're passing things and returning things as like register pairs on most ABIs. But that means that, if you have like basically like a word for your type information and maybe a word for your payload, basically all your primitive types can just kind of go in a register and you don't really have to worry about like having to actually point somewhere. You can still have
What,
like an int and pass it as a value.
what was I missed what the pointer pair was about.
So, if you have a uniform value representation, you probably want to be able to downcast into a specific type. Otherwise, it's hard to do useful things with your top type. There's just not that many properties on like
Yeah.
java.lang.object.
Yeah.
So you need some type information somewhere, right? And
Yep.
if you have something like, Java object, you have a pointer to an actual object, and that object has like a header with some type information.
Yeah.
But that pretty much requires, you have to box things if you're going to pass something around, ignoring later
Oh,
compiler
type classes. I
optimizations.
see.
So,
The
What
Java solution here is that the strong typing mostly removes the need for cast checks.
oh
So
yeah, yeah. I think when you consider like the scope of compiler optimizations that can kick in here, like a lot of that does go away, especially with like, object syncing and stuff like that. But you still have some amount of like parameter passing. And so if you're really concerned with performance, I think like, yeah, like the type class approach or like the Golang approach where you have like, where your top type is like some, quote unquote interface where you have like some data member, which could be a pointer, but it could also be like an inline word sized value. And then you have some other type information just inline. And so you have like two word value. Um, I kind of like that approach. That's my 2 cents. And I think Go
mm,
gets a pretty good amount of mileage out of it. Um, Obviously, that's still some cost compared to like a totally specialized algorithm or data structure on like unboxed integers or something. But it
right.
means you have to.
I'm
It
like
means you can sidestep the boxing.
There's
I
like the Java version is a little different from what you're doing with type classes or pointer pairs,
I
as
think
opposed, and
one
yet again different from totally inlining down to the primitives.
I think one of my problems is I haven't thought about the downsides to each approach enough because templates I don't want it to be Turing complete. I thought about that one enough, but for generics, I don't actually know what the cost is to have everything like box into pointers. And by pairs, did you mean like one of the pair would be like to a V table and the other one
Yeah,
be the
basically.
data
Yeah,
structure?
yeah,
Basically,
Okay.
instead of storing the vtable on the object, you
right.
pass around the vtable along with the pointer to the object, which means that that pointer no longer has to be an actual pointer. It can be like an int or something, and you don't have to actually have anything in memory, which can be helpful. Like, theoretically, once you inline, a lot of the parameter passing overhead goes away, but it can still be kind of complicated and, invite some, I don't know, just added difficulty,
Oh,
right? If you have to unbox things like java.lang.integer or something. Certainly a
Yes.
sophisticated compiler can see through that, but
I would
it's
claim
extra
Java
work.
lang integer is an anti-pattern and don't do that. Java
Yeah.
added that late in life and it works, but don't do it.
you know
Um,
what I actually did not do? I did not think about it in terms of how it's going to work with a JIT because a JIT can do a lot of optimizations with generics. And
Yeah.
I totally forgot about that. And I did want a JIT because of reasons that I won't go into today. But yeah, I was thinking about having a JIT. So I really should think about generics in terms of a JIT. And then I don't have to worry about the Turing completeness of templates.
By the way, if you're
yeah.
looking into this
The
on the internet, the keyword root is dictionary passing style. That's the way Haskell compiler implements type classes. There's a
Yeah.
very good article about this implementing and understanding type classes that basically walks you through the implementation. So that's the dictionaries are a common practice. Actually, do you also compare witness tables in Swift? Also very
So the choices here for performance costs are the vtables come from the object, so you only have one pointer, or you pass in two things. One's essentially a pointer to the vtable, your type class or witness table, whatever, and then you have a pointer to the bare object, and the object itself does not contain the type. And that turns into, moves the cost around as to who pays. The having the pointer in the object makes every object carry a pointer. Um, but you can drive that cost down pretty low, and it's actually worth doing because billion objects, billion pointers, it adds up. Whereas in the pair pointer, you have to pass them around all throughout the passing, but register passing pointers is pretty cheap. So I don't know. I don't know which one's more or less, but that seems like the obvious trade-off. I think the main goal for you is to make sure that there is a reasonable translation that you can then optimize, that you know you have a plan and assume the JIT cleans out most of the overhead. I've just seen plenty of places where people did something that they had no plan about where they were going with it, and then it was impossible for the JIT to actually, or any compiler, never mind JIT, any compiler, to clean it up. Not
Pair
to
pointers
mention,
is
cough
a
cough
lot more
JavaScript.
a lot more flexible, and it also I think it tends to optimize a little bit better.
So
It
which one?
it pair pointing is a little bit more flexible because you
It's
don't
more
have to
flexible. Yeah.
use like your object doesn't have to have a polymorphic pointer. You could be an int or something. You can still create a an interface to that object. So especially if you have really small objects, it's much better. If you have really big objects, it's less important. But
Yeah.
the other thing with the pair pointers though is like, yeah, when you assign one to them, if the compiler can follow that pointer, it can like devirtualize the calls. Whereas um if you're doing the like object contains vtable operation, then it can't always do that. Like you have to like tell the compiler, hey, the pointer at this address has this value, and like LLVM has like invariant groups and stuff, but like I don't know, it's just harder to like stick the metadata in there sometimes.
Which one now? There
Like,
is a real cost to all of these in terms of engineering a compiler. And that's
well,
important to think about when you're doing these
well,
things. Yeah.
like LLVM has like invariant groups, so you can tell it
Oh,
basically, hey, if you load the value from this address, it will always stay the same value,
gotcha.
right? And that's
Yeah,
something you can kind of use, but I feel like it's harder for the compiler to track in general than just hey, this is a pointer and it's copied when you copy this thing.
Yeah, I think that's way more restrictive in terms of implementation than some of the other solutions we were just talking here. Two
I think
pointers,
also
I say two register sized things, one of which tells you a type and one of which contains a value, which is possibly a pointer to some memory, or a pointer, which is easier for compilers to deal with, but to go get to the type, you have to pull it out of the
Yeah, because
object, which means every object stores it.
yeah, the thing is like the difficulty with putting it in the object, right, is that okay, if you have two pointers, that kind of maps real well to like SSA, right? So usually the compiler can like trace the type pointer and then devirtualize it. But if you have the pointer in an object and it's loading that, like often like there's an intervening store and sometimes it's hard
No,
to like
no. Java's lived in that world for 25 years. It's perfectly fine.
it does
Certainly,
Shouldn't it?
work,
no
but
Sure,
it's
but just
intervening
harder.
shouldn't it be the
store will
same?
ever alias with any load of a pointer header. So
Yeah.
no store will ever stomp any pointer header load.
Yes, but you still have to like annotate with all that metadata, so it's harder to implement. It's doable,
No, no,
but
I'm
it's
saying
harder to
it's not just
implement.
doable. It's cheap and fast. I lived that world. That was my world. This is an easy answer.
Okay, at least with LLVM, I think it's harder to optimize.
LVM is
I'm
kind
not
of
talking
bad at these
LLVM,
kinds of
but
languages. Like,
but
Everything's harder in LLVM.
say again.
Everything's harder in LLVM.
I agree.
Ben, you got cut off. Something about LLVM.
He
Yeah,
said every,
everything is harder.
Oh, everything. Yeah, well, okay, fine.
So, but it
Fine.
should be the same, right? If it's just
Okay.
passing around a pair. So if you've got an abstract pair
Yeah.
and you can keep track of the types of the pair, then it doesn't matter if you've got a pair of a pair or just a flat pair. It can keep track of it. It
Yeah.
doesn't matter where the pointer is. You still got a one-to-one mapping between a pointer and a pointer to the virtual calls. It's just a different hierarchical structure.
Yeah. Basically, yeah. Certainly in the land of Java, the types of the pointers start strongly typed by the nature of the language, but then the compiler refines it all the time and he loads the type and does an instance of check and then declares it's now refined and it's refined forevermore.
Yeah,
All
I
intervening
guess
stores don't matter. I don't.
it's easier with JIT, but if you're doing like static ahead of time compilation, I find it's like way harder.
No, it's the same compilation technology. It's just whether or not you
Mm.
It's just in
get to
time.
do profiling things early on about
I think
types.
it doesn't necessarily require profiling. It mostly is a matter of how much does your compiler know the high level type system of your language and like what your value layout is and like what are the rules around that. And LLVM is like a really good like general purpose compiler, but it's going to be hard to teach it about, oh, well, this field in my object is always this type header that I just never touch. Whereas I think there's a compelling reason, if you're rolling your own compiler, it's very easy to factor that into your effect
Yeah,
analysis.
Well,
It's
you
just a
can
matter
do
of
that.
specializing.
Well, LLVM is a low-level IR, so it's not surprising actually that
Yeah,
it
yeah,
would
yeah.
start for implementing something like witness tables optimization.
I think
That's
it's
why
very
Quick
sensible.
started on its own intermediate level,
the,
FIR.
the C2 compiler I would claim is low level. It does know about the object header as a special field, but that's kind of like it. There's
I
not a
think
whole lot of things that it knows about objects except basic types that you get from the
Well,
language itself or what you got out of the
well,
type
you get
checker.
you get into these strange situations. Let's say you want to say that this word of the object is the header, and I don't know, it's invariant and never changes. But then once you lower it to the point where, let's say, you actually initialize memory in the TLAB and you do store this, so now this high level invariant breaks because at this low level it's no longer the case.
Okay,
So
yeah.
how do you expect this
I,
like
I
consistently in different levels?
that never impacted anything to do with C2. There was a point where I bumped TLAB and I had to set the header pointer in, but that pointer, that store for that initializing pointer guy was at most tagged with a bit saying, I wrote, I'm allowed to write here, no one else is. It didn't change anyone
Well, but
else.
then you can once you are at this stage where you can see this kind of not yet formed objects.
Yeah.
Other optimizations, if they assume that the header, well, let's say the header is always initialized and it's always invariant, that can
They have to
interact
load,
badly
well,
with explicit storage.
in C2 at least, they have to load from the header word, which aliases to the store that sets the header. So the first thing one of these guys that says, I assume I have the header, he immediately aliases against the header word and
So
finds the store that sets it, and that's the value. So he doesn't, there's no change. Like the aliasing rules are completely identical in C2 here. Loads that deal with header things need the header word. They alias to the header word.
If you say it aliases with the store into the header,
Yeah.
then you don't assume that the header is invariant. Like
Yeah.
you
No,
explicitly
other
have
people.
this.
No, it's true. There's no point in not carrying the value around,
so
carrying
here's
the alias around for the header word. So
here's
I'm
the
pretty sure I
question.
did. I knew it
Do
didn't
you
get stomped when you crossed a call.
do you support like non-polymorphic objects? Because that's the biggest advantage of the two pointer method is like you can
Right.
have you can stick these objects in an array that don't
Yeah.
have pointers in them, and then you have better cache locality, and then you also still have the capability to stick them
Yeah.
into an interface. But if
Okay,
you're
so
always carrying around this pointer, no matter what, then you could just put it in the object, and I think that's a valid approach because then if you have multiple pointers, you don't duplicate that table pointer.
Okay, so Ryan, this was not what I was doing with C2 and Java because of the nature of the language of Java. But the compiler I use, the style I'm using, doesn't care if you run it the way you just described. It has no care on it. Like he just says, I got a value from somewhere. Oh, I know it's typed as a class word. I know I get an instance of check out of it, and so on. And that class word could come from over there or it could come from a load from the object, and I don't really care. I
Great.
mean, literally it was just the difference between the loading or I carried it or I got passed it in. Now, having said that, there's a fix for this in Java, but it's not, it's out of the language. You had to write it yourself. So I certainly did big data, no header solutions, but I didn't get language support for that directly. So I want to go back to what Arthur was saying. I'm pretty certain that I just carried the aliasing through. Instance of checks needed a class word they got from a load. The load of the class header would totally alias against the store against the class header. Well, hey, sorry to see you, Coach Eudor.
The difference here between what you had in C2 and what we have to deal with in LLVM is that in C2 you're fully in control of everything that the optimizer does, and you could carefully craft your transformations that they don't break anything.
Yeah.
In case of LLVM, LLVM evolves and new optimization can show up, and we cannot just review and make sure that everything is interacting nicely with the way how we design things. So we have to, instead of relying on these kind of understanding every optimization and how it interacts with our design, we have to communicate the invariance clearly. And if we communicate that the header of the object is invariant, well, it has to be invariant. And if we are lying to the optimizer and at some point it's no longer invariant because we're explicitly storing, maybe I don't have a problematic optimization today, but it can appear later when someone upstream learns something unrelated.
Your problem is you're using LLVM. As we just stated on here 5 minutes ago, everything's harder.
Well, yeah,
no,
we have
okay,
to.
Fine, but not
if
fine.
you're
But
using someone else's library, you're going to have
It
issues.
seems to me, but maybe I'm not the LLVM expert. Seems to me that this problem is somehow not. It never shows up. The whole thing of I aliased against a value. I have a value which I know is invariant, except if I see a store to it. No one else can write a store to it except the initializer code. I totally alias on it. If I see that store, it's the initializing store of the original class. Okay, fine. But I never had to do anything in any optimization pass that was specialized around the header or not. And I hear that you're doing something because you know the memory is invariant. And here's a store to invariant memory. So something's broken somehow. It's like, no, there's one store to the header.
There
And
is a way to indicate that this is invariant. There's an intrinsic invariant start, and you indicate that from now on, this memory allocation is invariant. It exists. It's because it's fault sensitive. It's not as like it's harder to use this fact. You need to analyze whether the context where you want to check for aliasing property, if it's actually dominated by this kind of intrinsic. So not every single optimization reliably uses and takes advantage of
all
it,
right.
but there is a way to encode this in LLVM as well.
So maybe one of the difference here is that I only ever have SSA with the edges, and I only ever honor them. No one can ever not honor them. And so if you had an edge to the store, you had to have an edge, and if an edge pointed to the store of invariant memory, you were stuck behind the store. And I didn't do anything different for that particular memory over any other piece of memory. It's certainly the case that final fields in Java had all kind of lying games going on that this fixed. You have final fields that you ought to set, but you got to read them before they got set, so you got to load. You knew you had a zero or you didn't or whatever, and that was still fixed by having the store.
My tentative understanding of this sort of situation is like it's mostly a matter of priorities where like I would fully believe that LVM can probably see through like if you set the V table on like a C++ object in the same scope or in the same, inline
Yeah.
scope. I fully imagine it can optimize that away. I think the big question is, you pass that into some function that just takes like a void star or something. Like, can it actually figure out the effects and the aliasing? And I'm a little more dubious. And I think, a lot of it is less because LVM doesn't have the technology to do this and more like it just doesn't actually make a lot of sense in your aliasing model when you're compiling predominantly C to like try to like figure out like a really strict like type-based aliasing or something. Like my understanding is LVM actually ditched type-based aliasing for the most part at some point and mostly just does like, points to analysis.
Right.
I heard some stuff about them like reintroducing it. Whereas like C2 or something, I imagine, I mean, I don't know that much about the internals of it, but or if you're compiling a language like Java,
No,
generally.
C2 does type-based aliasing.
Yeah.
And it has
and
a
so then,
strongly typed language it's compiling. It's not compiling C code.
so then once you do that, I think that changes your overall approach to aliasing and it makes a lot of things easier, but also it would work really poorly for C in a lot of cases.
No, you're right. And that's part of what Arthur's fighting is the compiler does C code, which you can't do the trick I just mentioned reliably.
Yeah.
And I can in compiling Java. I can both
And
do it reliably and cheap.
there is mechanism for type-based ALS analysis in LLVM, so I don't think it was
Well, okay, you have the
ever
mechanism, but you have to enforce it, right? You can't, there's no cheating allowed.
Well,
Like-
with the existing mechanism, you annotate your memory accesses with the type information, and then the LS analysis will use it and will distinguish different locations based on types.
But no one can do a cast that cheats. No one can say, I cast an A to a B.
I got a related question that I don't want to interrupt in. It's about
Well, you did
aliasing.
already, so ask it.
Okay,
Later, ask.
If Arthur needs one, then sure. I was okay. So I know that in most code bases, there's going to be like a lot of spaghetti code, and it's going to be really hard to track like all the aliases. But I was wondering how friendly can a language be where it tracks all aliases? Because I was thinking if I redesign my language, I'm going to want to track every aliasing, and I'm not sure what what problems I'm going to hit.
You
But
get to different levels. You get to different levels of precision with your aliasing. All aliasing starts with the assumption that you can be infinitely bad and you approximate in order to keep the problem tractable at all. Now, what is your approximation? Some approximations are sharper and some are weaker according to whatever. In the land of Java, because of the typing rules that come in and the hard requirement for honoring the types, it makes it really easy to have a simple solution, and your types are essentially perfect at the field level and essentially non-existent at pointers to the same fields or to, say, chunks of arrays, unrelated pieces of arrays. Like I have to fall back to classical vectorizing compiler analyses if I want to see that two different pieces of arrays alias or not, because I get two ints as the indices and the ints are equal or not. I can't tell other than do the same math everyone else has been doing for 40 years. But if I have a pointer to a person and I point it to a cat and I pull up the name field, well, cats and people don't come from the same hierarchy. So even though the field might be the same name, they're totally different alias. They will never ever stomp each other. And I can store to one and load from the other. It's all totally free. And in fact, the representation you get makes it impossible for a person name field to ever care about a cat name field. They cannot interfere in any way. No person name operation will ever run across or deal with or dodge or have to say something about any other cat-based name field. It costs literally zero to maintain that knowledge.
I don't know if you,
On typing.
I don't know if anyone researched this, but I did a little bit of the aliasing with my invalidation rules.
Yeah.
Basically, you can return a reference to some kind of internal data.
So you can make a reference to some other piece of memory.
Yeah, so in my language, you can return that if it's within the object, and then the calling code has to be able to see the object so it knows the lifetime. Like I got that condition to work, but I don't have like other conditions where like you have a global variable. I'm iterating on top of the like it's a vector, so or a list, and I'm iterating on it. I don't have any logic to like know if something else added to it while it's iterating. My cheat is to just use ints. I mean don't use an iterator objects, just use an index. That's my cheat for now, but I'm just thinking about like how do I have better aliasing analysis, and I don't think it's a solved problem yet, or
it's
what
it's
the biggest
index,
problem
not an
is.
iterator
It's
object.
not solved, but there are solutions that are well understood that work well in their domains, and the one that works for C and the one that works for Java are different.
Yeah, I
Yeah, I
gotta
think
look into
there's
more of those. I don't know what the biggest problems is in terms of friendly code.
I mean, I think that's sort of the like the human interface side of this is maybe the most sort of unclear, I think. I mean, there's some solutions that are pretty easy and seem to have not a lot of impact on user interface. Like I think type-based aliasing is a pretty good one if your language has strong types. Like most people are writing types anyway, there's not a lot of burden to that, just to tell the compiler about them and have the compiler use those to determine that things are different. What I think you're also getting into though is like another facet of this, and I think alias analysis is like it's like a bag of strategies. You want to have as many different things theoretically to like, distinguish different things, and like you can definitely like add more mechanisms over time. But I think what you're getting into specifically is like some sort of region-based analysis to distinguish aliasing, or something maybe analogous to like what Rust does, or maybe you do it somewhat differently where it's not so much a requirement that you like abide by these things as Rust does, but maybe you try to like infer those lifetimes or something like that.
Yeah,
You
lifetime
can definitely
maintenance
do all
and
that.
aliasing are related, but they're still fairly
They're
different
definitely
topics.
distinct, but it is you can definitely leverage those to get aliasing in some of these ways you're talking about, Levo, where it's like, if you have a vector, like how do I know that I'm like, if I'm modifying that as I iterate, how do I know? I mean, for one, you could question, is that memory safe? But then the other one is like, well, how do I know if these things like alias for optimization purposes, like maybe that affects the way I like unroll that loop or something like that.
Yeah.
And so, if you had a Rust-like system, you do get some of that kind of falling out of the region system where like if you have the knowledge that if you mutate something, you're the single reference to that thing, well, then you also know that you're the single reference to that thing, so you can't alias with anything else, at least nothing else that's writing it. And that's, helpful. And you could definitely try to construct a system or maybe just try to infer this after the fact where you like figure out like, okay, where do I have like a unique reference to these things? Like, I feel like there's probably like you could definitely tackle this kind of ad hoc and like there's a bunch of different dimensions to this like
It's been tackled ad hoc for the last 40 years.
I just thought of something. Oh, go ahead, Aaron, or Ryan.
Yeah, I was going to
Wait,
say,
all right.
I know LLVM is getting a lot of hate, but LLVM does have a global aliasing pass if you enable link time optimization that can like detect like, oh, this is the only possible function that edits this global variable, so therefore it must not alias. If you turn on link time optimization, you can get that.
This is a design philosophy choice around the type system. What I get out of C2 doesn't require any effort,
Well,
any
you
global
don't
aliasing
need
pass to give me perfect aliasing among different fields. So I get the perfect aliasing at essentially zero cost, comes out of the language. Um, on the other hand, I don't get any help for things within array collections. But you don't add any other languages either. And then the other hand is also that I require the strong types.
Yeah, LLVM does have type-based annotations. You just stick them in the metadata. There's called like an aliasing group or something, and
For the
then you can do.
type-based aliasing to work, you have to only do valid type steps. You have to have the strict aliasing, the strict typing going on, and it has to be correctly honored, or you can break the rules, and then the optimizer has to
Yeah, yeah,
decide if you've broken the rules, what the hell it means.
yeah.
Can
Don't break
someone,
the rules.
can I get a link to the docs in the chat?
Oh, they're in the Discord as well, but hang on, I'll just dump it in.
Because I
Yeah,
just thought there's like a piece of code that I think is going to be completely unreasonable to write if I do some aliasing. So I'm gonna write it up and show you guys.
Yeah.
I will say, like, I think the approach of alias analysis driving a lot of your language design decisions is, I think, maybe maybe not misdirected, but it might be kind of overkill. Like the like type-based aliasing is pretty valuable if you can get it, but I think a lot of languages with strong type systems can get it pretty easily. Beyond that, like if you hook that up with something like, LLVM figuring out like which globals are accessed where or something in some sort of global optimization pass, like if you can do that, that's probably pretty good. Like there's some more stuff you can get from like, Rust style like
So
limitations
back
about
up a second
pointers
here.
alias and stuff.
So that type-based aliasing thing you just mentioned, all those globals all fall in the category of singleton statics. They're their own alias class. No effort. You get it for free that you know exactly what goes on with them.
I mean, I think there's yeah, maybe. I guess if you know like exactly, I think the challenge is like, if you have like a specific global that you
Wait,
like pass into some function that takes like an object pointer or something, like,
I
how do you make sure that that aliasing information goes through? And you can do like an interprocedural analysis to recover
As
that.
soon as
It's
you
not
say
crazy.
I took something and I cast it to object and threw in my types, the guy who received it got an object. He has no type on it. He can't do anything with it.
Well, yeah, so that's what I'm saying. Like but you could still do some, if you have the compile time to spend, which I think LVM does, you could still do like an interprocedural analysis and see like, well, maybe there's only one call to this function and it's specifically this global. So then I'd like actually compile the function to only take that global if it's not exported or something.
Well,
And
you're
I think
getting into
that's
the
like,
jitting
uh,
versus not or whatever.
oh yeah, if you're
are we still
jitting, you can do some speculative stuff too.
It,
But
are we still
you
using the Google Doc?
Google Docs are up and available. I'm sorry, what did you need?
So the announcement link is to one of the January ones, and I can't edit it.
I'm
Yeah.
sorry. What?
are you
Okay,
sure?
I
I have a
may
link
have
to the
handed
current
out
one.
the okay.
Oh no,
I apologize if I sent out the wrong docs link. Let me correct that first.
my email
At
definitely
least
is
in
the
the
current one.
Discord, let me make sure that people can go. And it's in the chat right now. You can get the Google Docs link. And the
Where?
announcements page says blah 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 ends in Y00D of something. That is the wrong fucking link. Oh my
Okay,
God.
where? Wait, where in the chat's the doc?
Okay, so if I go to the Discord announcement tab, so in the chat for this Zoom call is the correct link.
I pasted my code into it. You guys can review it
Yeah,
whenever you feel.
I'll bring your code up in a second. I put the correct Google Docs link in the Discord pound announcements. I apologize. All right, now let me try to screen share. Na, 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 na. And here is Levo trying to write stuff. And he's trying to say slice 8. Yes, exactly. Okay. So in the type-based aliasing, because these are the same type, they alias in my type-based aliasing. They just do unless I can prove otherwise with something outside of type-based aliasing. So if you happen to have called my func where you said new slice and a new slice back to back, and I have two new slices, well, or a new slice and one came from before, I'll know they don't. But otherwise, I'll just give it up and say, yeah, they alias. I'm done. And maybe LLVM would do something more clever than that and get a better answer.
Yeah, I think this is why, like, if you're after like ideal aliasing performance, you want to have layers to it, where like it's really cheap and easy if you did know that these were like a slice of ints and a slice of floats to say like, oh, well, those just aren't the same. And that's like, you're done, right? They don't
Yeah, and
alias
no,
and
if
you can
it's
just
ints and
optimize.
floats, I'm done. They're different. I'm done. Yeah.
But yeah, in this case, you would want some sort of like in terms of exactly how that looks in terms of annotation, you can kind of argue about that. But like, you could make it so that you have to like annotate all these things. It does create like a function coloring situation because then, if you have something that, I mean, you could maybe have some subtype hierarchy that makes it a little better, but like, you could not pass the second one, or I guess you could not pass the first one that requires that A and B don't alias to any like, higher order function that then, passes in some pointers that might alias, right? Or you need to annotate that
No.
thing. Like,
No, the solution, if you have this demand that A and B do or don't alias, I would instead start out by putting an if test. If they're aliasing this code, else that code. And I wouldn't, I mean, I don't think this is reasonable annotations, but if you have a language where you want to say that this don't alias, um, then there's an assert, and I don't know how to propagate that through the type system.
See, that's the thing, because I'm thinking like if I have this alias keyword, people are just going to be very angry because there's going to be aliasing all over the place,
Yeah.
and it's just going to be layered with these, and that's like I'm trying to avoid like having a verbose language and verbose like type system and
Well,
all
right.
that.
What gain do you get out of using the alias keyword? Or you're saying they don't alias or they do or something. I mean, for things that are array slices, you get a Daxby, Saxby, some kind of optimization overlap. If you're heading for GPUs, it's probably not enough. And if you're heading for classic runtime, I'm just executing code, somebody will throw an if test in on a big array. On a small array, I don't care. It's too small. Nothing happens. On a big array, I'll put an if test in, and you don't care because it's too cheap to throw an if test in. And now I know they alias or they don't.
Actually, it would have been a better example if I had one of them immutable. But anyway, I was just thinking that like because I don't want a lot of languages that have like a strict type system are very difficult to use. So I don't know how
So this would
difficult
be
the language.
Java is difficult to use. I think a few million programmers would disagree
I
with
would
you.
I would 100% disagree with that because things that are not typed are insanely hard to use on a large project.
well, but what I think he means is, strictly typed to the extent that aliasing is part of the type system probably does make the language a little bit more annoying to use, right? Like this is a level beyond Java. It's to have like compiler enforced aliasing.
I'm
Um,
sorry. Compiler Java does compiler enforced aliasing.
or sorry,
Right.
sorry. What I mean is like, these annotations like Leo was talking about, right? Like where you have like an
Okay.
alias declaration with A and B. At least that's what I'm understanding him to mean by strict. Um,
Yeah. You're trying to put in compiler optimizations into the language and then getting the people to do the optimizations for the compiler. Yes, that makes programming difficult.
Yeah, but it would make it too difficult because there's certain languages have a reputation for being difficult to learn and use, and I'm trying to avoid that.
My guess, I mean, I think so. So I think my question is, how much do you prioritize performance? And do you prioritize performance so much that it should actually be a compiler error if the compiler is not able to optimize something? Because I think usually the approach here is, well, throw this at the compiler and probably, through inlining and through maybe some sort of interprocedural optimization like LVM is capable of doing, uh, you could probably figure out this aliasing declaration automatically, and the programmer never has to worry about it at all. The only problem with that is that, maybe you get that in a lot of cases, but there might be some holes where like the compiler can't figure it out, and then maybe you have some sort of performance cliff where suddenly your performance is
Yeah.
worse. Even in those
You said a
cases,
lot of things that are very open-ended or not well defined. So performance has a value to some people that is more or less than other people. Ease of programming is better for some and more or less than others versus performance. And there's this spectrum. If I'm trying to get my fanciest new shopping model out for women's clothing dresses that do blah, 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 I probably don't care about performance, but I have to beat my neighbor to the market, and the first person in the market wins. And if I'm computing tomorrow's weather and it takes me all day, then I didn't get it till tomorrow, then it didn't help and performance wins. And if I'm doing the best AI model and I'm charging $100 billion of power, and if I get a 5% reduction because I got a better performance, well, that's money and that wins. So it varies according to what your problem is.
I just realized that if I want this to be friendly to C++ programmers and C++ interrupt or C, this is not going to fly because it's going to alias all over the place.
You can do no alias instead of alias, just like the default is anything may alias, and then you're like, okay, here's a no alias in this special case where I've like guaranteed that that's the case, and then
I
that
mean,
introduces an additional optimization.
isn't
Can
that
I?
basically what C did when you do things like memcopy, that there's a way to promise that all of the inputs don't overlap?
No,
Yeah, this is
Memcopy
like
memcopy
status
does
quo.
Memcopy
yeah.
does the runtime test.
No, it's defined to not do that test, but it's undefined behavior if they overlap. But some compilers are like, oh, people are
There is a
writing
version
broken
of the
code.
memcopies that says if they overlap,
Yes,
they're copied
Memmove
in
yes,
does the
such a
check.
fashion that you
that's
don't lose any bits.
technically that's memmove,
Ah,
which is
okay.
memcopy. Technically speaking, according to the standard, it's undefined behavior if they overlap. In practice, a lot of the compiler vendors are like, people keep writing broken code, so we're just going to check anyway
Yeah.
because
The
I
check is
seen a
actually pretty cheap too.
The
Just
only
I
why
see
not?
There's also restrict keyword in C. The only problem with restrict is that no one knows what it means. And if you think otherwise, then try to prove formally what restrict should mean in mechanized formal semantics in C that you can verify the compiler against. And if you cannot do that, then you also don't know what restrict means. So far, most humanity fails this test.
yeah,
I don't
restrict
know.
is
There's a lot of people on the committee. I think there's at least 3 people alive who know what restrict means.
it basically means that the
I am not one of
arguments
them.
can't alias like following provenance.
No, I think
The
just what
things.
Matt just said was that it doesn't mean exactly that because that doesn't somehow isn't well defined.
Well,
And
no,
I can
like
totally believe
like
that. That has been a
Provenance
common problem with
semantics
languages.
isn't exactly formalized right now. I mean, there are several candidate provenance semantics formalizations, but they have slight differences on how you treat things like integer, pointer, pointer to integer, and it's a rabbit hole.
So I definitely seen Clang generate memmove instead of memcopy in some of my code. But going back to this, I'm just thinking about like if I do this alias keyword, basically no program is going to be easily portable to my language, and I don't know if that's a good idea or not.
Is it no
So
alias keyword or the
I
alias
think this
keyword?
is this is sort of the Rust problem, right? Where like, Rust doesn't do exactly this exact kind of aliasing, but it has a similarly kind of compile time restrictive reference system,
Yeah.
and it does complicate rewriting and refactoring things into Rust, and it's like kind of a big problem in big industry code bases to actually like
Yeah.
port things over to it, to the point that like there are whole languages that exist just to be Rust, but like maybe more friendly to C++, like Carbon, that like Google thing. Um,
Okay.
so like
oh my
it is definitely a
God.
cost.
Carbon is a joke, man.
Oh
I
yeah, I
hate to
know.
say this as a Google employee, but Carbon is awful because it's like, hey,
I mean, I don't want to be
let's
too mean to
let's
it,
Okay,
but
wait, let's
remove
not dwell
pointer
on.
arithmetic and pretend to be a C++ replacement.
I think my 2 cents on the overall issue is you should figure out if this is a problem for your domain. I think the most important thing is in PL design, figure out what the actual domain of your language is. I can imagine some use cases, like Cliff was talking about, GPU programming. It's super important for certain like really high performance kernels to make sure that things don't alias and are absolutely max performance. If you're specifically doing that, then I could imagine this being a pretty useful feature because you're not writing a huge volume of code and the aliasing really, really matters.
Yeah.
If you're not doing that, my 2 cents is like for a normal CPU language in current year, like I would just like maybe do some type-based stuff, see what the compiler can figure out after the fact, and then if that's not enough, if you're finding cases where like the compiler is not able to figure out the aliasing enough, even after some sort of like interprocedural optimization or something, or maybe you find out that like the compile times are prohibitive for interprocedural opt. You need something more static. If you have a specific problem like that, then I would consider, hey, let's add some annotations. It's very easy to add annotations after the fact. They're still going to be a little annoying to use as like an end user, but like
I think in this case, for Levo's sake, I would claim the annotation is fine. The implementation just does the test and aborts if it fails. So you get a bug, like a divide by zero bug or a null pointer exception bug. And then the compiler tries to get rid of the test, but the test is relatively cheap if you're doing a big array thing.
I mean, yeah. So like you could definitely implement this.
Yeah,
I think
there's an implementation that works.
I'm just also agreeing. I think that the concept of having to write these alias declarations on everything is
Yeah,
like I would find that to be a pain if I was a
yeah.
programmer. So I
Oh,
would
we'll do
rather it
that.
was inferred unless there's like a very
Yeah,
compelling reason not to.
yeah.
Um, yeah.
Well, yeah,
What
otherwise you end up with the Java throws problem where you just have a list of a huge
Oh,
number of
throws was a giant
constraints.
mistake. Yeah.
part of the reason why is to make the code more clear because I don't know if I showed you my language, but my language also has when you at the call site, if you want a variable or parameter to be mutable, you have to write mute next to it. So I don't know how much that makes people annoyed because no one used my language. But I was like thinking that alias might make it more clear that things might be if you modified one, the other might change. But I never. But there's also the problem with global variables, and I don't know how much more clear this would make things and how annoying it will be. And usually the answer is try it and like find out. But it's
You
a lot of
code in
work to
anger.
try it. I got to implement a lot if I want to try it.
You have
So
to code
I
in
was
anger
just
a while in your own language or in a language to know whether or not you're annoyed by the, yeah.
I guess I will
I
say, like, I'm not sure it is actually, like, I would not imagine that this is super costly to prototype. Like, maybe the aliasing of specific variables is a bit more annoying, but like, you could also start by just flipping this and having like a no alias annotation that you put on the variables, basically the same as like C, C++ restrict. Although, I think like a lot of things with C and C++, you like try to put something in your language that follows the spirit of it, but not necessarily the C standard, because the C standard has some weird exception that like no one has ever heard of. But you add some sort of no alias annotation, and you can start playing around with that, and that should be a pretty easy thing to prototype. I think you could hook up no alias to whatever your compiler backend is, and a lot of them should probably support it, or maybe at first you don't even try the performance angle of it, and you just see like how does this feel to
I think
write.
you were doing
Um,
your own backend or you're doing TCC as a backend. So there's
uh,
no
I I
typeface
have
going
a
on. No annotation.
I have both LLVM and
Oh,
TCC as a
okay.
backend, and I think if the sanitizers for C support this, I'll try with that. I don't know. I don't think they need that restrict or any kind of no alias keyword, but I should look into that. Yeah, that would make it much easier to prototype if I could just use a different language to prototype it.
So my only concern with this design is it's going to just color all your functions red or black,
Yeah,
and
me
then
too.
you've got to what, and then what's it's
Yeah.
going to be everywhere. But how also do you deal with the barriers between them? Do you have to explicitly check and throw
Yeah.
your crash?
Yeah.
Is it just something the compiler itself can prove?
It would be a
There's
compile time error.
yeah,
Well, you have you reach a point where you can't tell at compile time. You must throw in, you either ignore it and you alias, you cheat and break the rules, and then the code is wrong and something weird happens, or you test, and then you have to decide panic, throw, catch, something happens here. An easy answer is to just panic and report, my func slice A and B alias, and with a no alias keyword and error done, crash done, and fix your bugs.
For
But you're not going to get this as a
mutability,
compile time error.
for ownership and mutability, I think I have it all correct, and it's been going fine. I don't know if this is going to be any tougher than those, but I haven't coded in anger in my language, so I don't know if I actually made mistakes someplace. I'm willing to have cheat a little bit in the standard library because then I could just audit the code myself and make sure everything is correct. But I would prefer not to cheat outside the language because you can get really nasty bugs. I mean, outside the standard.
So is I'm calling my func with two random slices. Do they alias? They do if rand is the same value, and they don't if they don't. So what's the compile time check here?
See, I haven't even thought about having that keyword inside of like a member function or a member field. Um,
It's not a member field here. I'm just making new slices. I'm just saying this requires a runtime check. The compiler's not going to unwind random to decide that these things alias or they don't.
Or I mean, it requires either a runtime check or that your compiler is conservative about this and assumes pessimistically,
Yeah, and then the
like
compiler
maybe
can
they
say, I
alias.
can't prove they don't alias, so error. Yeah.
Yeah.
Well, there's two solutions that I see. One is nothing in the array is allowed to alias anything else, in
Yeah.
which case,
In case
in
what?
which,
So random here, random of, suppose n is
yeah,
whoops, n is 2, I 50-50 get 0 or 1. 50-50 they alias, so they don't.
I
Suppose
see.
n is 1, I only ever get slot 0, they guaranteed alias.
See, a lot of my solutions is just cheating. I use literals. Like for slices, you
Yeah,
have to
but
say
okay, you can't just go
0 to
literals
n.
everywhere. I remember this from before, and you're like, all literals all the time. I'm like, no, you just can't do literals all the time.
Well,
You
that's what
kind
I'm
of have some
wondering.
very
How far can you get? Because I was able to get pretty far.
I mean, there is like a logical conclusion to that. It's just really hard, which is you start by having like literals in your type system and intervals in your type system, and then you start having like integer constraint solvers and stuff. And you can,
right.
you
You
could
get
say
right.
like I require that you actually do statically prove that these don't alias or something.
Yeah.
But then, you have to start writing like proof carrying code, and all of a sudden you're like
Uh-huh.
ATS or
And
something, and that
people have
gets to
totally
be
tried these
tricky.
solutions.
I think it's super interesting, and I like it's an awesome angle, but it's like also famously very complicated. So.
Hmm. And it's
I
hard to write large programs, and also the compile time generally sucks because the proof solver is just ludicrously expensive. So as a general purpose solution, it never caught any ground, these kinds of heavy duty solvers.
I think maybe this would be very easy to implement and cheap if you have a random for both indexes to be inside of a variable, and then have it if statement say uh, both variables are not equal to each other. And then also you would have to make sure it's less than n, so it knows it's within bounds.
Yeah,
Um,
assuming the bounds are all correct here for the language, whether you're one based or zero based or whatever.
Yeah, so I would definitely have a compile error unless there's an if statement that says temp1 and 0 is are not
Right,
equal.
right. So this is error by itself because I can't prove. And then there's a
Yeah,
version that says I have a minimalistic solver that says, temp 0 is unequal to temp 1. This is okay. And then,
yeah.
the else clause here is the user decides what to do if they are in fact going to alias. Whereas
See,
my prior solution was I just put a test in and then panic, where the solution is I panicked. If A equals B, panic.
I do want to like
in the latter code with temp 0 does not equal 1, I found that that kind of code actually doesn't make anyone annoyed when writing.
Which code?
The temp 0 and 1 in the second block. The if statements to check if they're not equals to each other. I found that people don't find that code irritating because it's something that makes sense to check and is fairly readable. So I find that that code is like fine to write. But now this panic one, yeah, I definitely need language support for asserts and panics because I definitely would want to allow it if it's been checked inside of an assert or a panic.
So Levo's proposed solution. I'm just picking on you because you started this.
Yeah. Yep.
User writes the alias check.
Yeah, like would you guys be annoyed at this? Because I find this totally fine.
I mean, in the land of like null pointers, it's totally easy to get in the language itself. In the land of like arbitrary integer math calculations, you have to write a provable expression, provable to the compiler, however stupid or smart the compiler is. And then you have to write an alternative. Hey, in fact, they're not. And in many of the cases that I deal with, if I can't prove something and I know that it's true, but I don't know how to tell it to the compiler, I'm okay if the compiler emits code that panics and dies. It's my bug.
I think yeah, as
So
you
replace A equals B aliasing with just null pointers. Hey, I know there's no null pointer here. It's not supposed to be null. Okay, boom, I got a null pointer in the debugger. Crap, I got a bug. Okay, fine, I do. I go hunt it down, fix my bug.
I think unless your solver is very sophisticated, which becomes complicated, you kind of increasingly approach the fact that you're just basically doing runtime checks, but you are asking the user to write all of them explicitly instead of the
Yeah.
compiler doing them automatically.
Yeah.
And I think if you're basically in the situation that like you can't really do sophisticated solving, so you have to sync like an if statement around every use of variable like right before you pass it into something,
Uh-huh.
you might as well just make the compiler do it. I also kind of think this is maybe diminishing returns where like aliasing is not so valuable of an attribute that it's worth spending this much time on it unless you have like a super compelling reason like, oh, this has to be like the fastest thing on a GPU or something.
Let me hand you a counterexample or an example of what you said where it didn't work. I coded in Elm in anger for a good year, and they had this theory that if you loaded from an array and you were out of bounds, you got a maybe out of an array, and if you're out of bounds, you got the empty or error, whatever you want to call it. But if you could prove that the bounds to the compiler to the language system, he would let you get away without having the extra syntax. And generally speaking, I couldn't prove it. So generally speaking, every minor array access, I had to sync a handling of a junk value that I knew couldn't happen, and also would be in the hot performance code all the time. So I think that a check on every array element that you're in bounds and your user has to write the handler for it being out of bounds is like not tenable. The Java solution
Really?
is the check is happening, but the failure mode is panic. I mean, you can catch array index out of bounds exception, but typically it's just might as well consider that a panic.
Yeah, don't do that.
Don't catch it. I let the debugger
No.
catch it. The VM totally throws it. The VM can catch it and then hand it off to the debugger, and that's great. I love that.
Yeah, yeah, that's fine, but you don't do that.
But I don't do that. Exactly. Now, I certainly have seen code where people do that, and then they try to, do something smart with it, but it never, it's both slower and harder to read and understand. Don't do that. Yes.
Yeah, first thing, go through, find a whole bunch of exceptions in the code base. Cool, let's delete all those catches. They could just bubble up. We can find those errors. Thank you very much.
Yeah. Yes. The catch and rethrow. Oh, we caught it. Oh, I don't know what to do with it here. I'm going to rethrow it. Oh, I caught it again. I don't know what to do with it. I'm going to rethrow it. Caught, rethrow, caught, rethrow, caught, rethrow. Finally, it bubbles up to a log file. And then, a week later, I'm sorting through the logs, going backwards through the try catch, try catch, try catch, rethrow, stack over and over until I finally get the base of the throw. It's like, fuck you guys. If you
That's fine.
didn't,
It's the try swallows. Oh,
yeah.
try
Oh,
swallow,
well,
try swallow. They're worse. No,
yes. And then
at
try
least got a log
swallows, of
file.
course.
So which is annoying, writing this or looking through the log files?
Oh, totally both. The much better answer is panic. Don't allow a catch. Then run it the debugger and let the debugger catch. There's a special out of language feature. Debugger can catch it and stop there and say, here is your stack trace with everything, and it's all wide open. You could stare at the variables and figure out what the hell happened.
So exceptions are bad, panics are totally fine. Is that how most of you feel? Because I think I prefer panics. I definitely prefer panics over exceptions too.
I mean, I have a somewhat different take, which is I don't think you should really consider it an error. Like, I would say, like, unless you have a really compelling reason, having the wrong aliasing or being a bit conservative about these might alias is mostly fine. I mean, like, if you're writing C++ or something, the default is that basically everything can alias with everything, and compilers can recover a lot of the information about what actually does alias with stuff. The main thing you're worried about is either performance, which you can mostly let the compiler handle, and then there's like a couple cases where the matter of aliasing or overlapping does matter, like memcopy. But really, those are only problems from a like safety perspective. Like in the case that you actually have like a memcopy where you are like violating the type system, right? Like most of the time, you're not going to worry too much. Like the problem is like you have like a user space bug, right? Like memcopy over strongly typed things, even if they overlap, is well defined. It's just maybe not exactly what you want. But like that's a user fixable bug, and I'm not even 100%
Right.
sure that I want that to throw an exception so much as
Yeah,
I just fix my
should
code
just
or
work.
something.
And if you wrote the
I
bad code, you
was
did it.
I was thinking that this actually makes the code more readable because then things are never going to overlap unless it says you can.
I mean, you can always annotate everything and you could add a comment on every line explaining exactly what everything does,
Yeah.
but I don't want to spend all my life doing that. And I think you really hit diminishing returns where like 99% of cases, I feel reasonably comfortable saying like this mostly just doesn't matter unless it's like super perf critical. And that's even then, it's like rare that
If you're
99% of your
super
cases are super perf
critical,
critical.
I like my solution. You have a bug. If they're going to alias and that's going to break how you do things, you got a bug because it's perf critical, and the alternative when they would do one or the other changes performance.
Yeah, and I
So
think that's
you should panic and
reasonable.
fix it. Fix your bug.
But also,
Well,
like, I would not do that as
you
the default for everything. Like, at least that's my 2 cents. I think,
Yeah,
you should have that as something you can opt into if you like really care about a
right.
small critical section of code, but it's just not that important that like I would want everything in the
Well,
language to have to worry about this.
another thing you could think of here is that this is totally readable by a compiler, this if A equal B panic. And the compiler should know that they're no longer alias after the rest of this function, at least. They don't alias. And then go do the fast no alias thing.
I think
you
I need
should
a
also be
strict.
able to see if the user's checked it and called something, the compiler should be able to see that as a common example and can't get rid of one of the checks.
Yeah.
But you need the panic anyway because that's your language. You put a language construct in enforcing something, and well, if you're not going to enforce it, then it's not going to do
It's
anything.
not for, yeah, exactly.
Yeah,
Certainly
it's yeah,
C2 will look at user like null checks and fold them into his guaranteed language required null checks and optimize around that. Yeah, absolutely.
I think I need a strict keyword, like using strict or some kind of strict at the very top of the source file. And then if you don't have the strict, you just get the panics automatically, which probably make everyone's lives much, much easier. I kind of think I'm the
No, wait,
only
if you
one that
get if
thinks.
you say it's strict and you're expecting them to not alias, you should do the runtime check and panic and die.
No, I mean,
I thought I heard
strict
you say
makes.
backwards.
No, I mean, strict makes the compiler force you to write the error
Oh,
handling.
I
If that,
see. Yes. Okay, fine. Well, one
yeah.
of them
So
says if I can't prove it, the user has to prove it for me by writing it.
yeah,
The other
yeah.
one says by default, if I can't prove it, I put the runtime check in. I hope to optimize the mostly way, but there's a runtime check.
Yeah. So I kind of think I'm the only one that thinks marking aliases will make the code more readable. Am I the only one that thinks this is true, or does anyone else
This
think?
is a funny case where if you've coded in a type safe language like Java all the time, where you can't break aliases outside of arrays, you can't break the aliasing, you never even think about it. There's just nothing there.
I know a
It
lot
can't
of
be
people
broken.
experience like they'll just clone things because they don't want to accidentally mutate data. Like I seen that happen.
No, okay, so then there is the somebody says I don't know whether it's going to mutate or not. There's no mutable keyword for Java or const keyword for Java that means anything. So yeah, there's that's missing.
Yeah. So
and
this was
look,
like
as
you
for
help.
as for readability, if it's an optional thing, then if it's not written, it's not readable. So who cares? But having a language construct in there for that 1%, being able to use it for that 1% is really, really good, especially if you actually need to ensure that these things don't alias.
I mean, I think it's good, but it's also like this would not be my like P1 feature also. Like there are so many things that are more important than
Yeah.
this. Like, aliasing, like even in, I think if I remember correctly, like there are like some benchmarks about this, like because, when you're comparing like Rust and C++, as people like to do recently, Rust has stricter aliasing restrictions and it can often generate more like restrict annotations than idiomatic C++. And even then, like the performance difference is just not actually that significant. And like, and most of the time, like certainly in very few cases is it anything resembling a correctness issue. So it's really mostly about performance. And the performance is like pretty marginal. I mean, it's not nothing, but it's like in the single digit percent is my understanding.
Yeah.
Is like the difference of like fully restrict annotated C++ or Rust code or something where like all your slices and your pointers are like very well annotated versus like completely unannotated and you just assume everything aliases and you let the compiler try to figure it out again. Like I would prioritize maybe any other aspect of language
Until you
design
hit
over this.
towards 2x performance numbers, most people would rather have an easier coding paradigm and give up some speed, right? There's some large amount of performance you have to be gaining by doing a more complicated coding paradigm.
I mean, that's basically what they put on the tin of Clojure was we're half the speed of
I
Java
have
and
to
half the time
run
to write
for
the
10
code.
minutes, 5 minutes. I'll be back. So I'm sorry, please carry on without me.
See, I claim that in large code bases, this alias keyword would help to know, like, so things can alias and you can clone the object or do whatever you need to not
I mean, I
accidentally
think
mutate.
it's you really have
I
to
tend to want,
prioritize. Like you have to understand like there's some amount of value you can ascribe to this, but how much value is that versus all the costs involved and all the other things you could put in your language and spend your time doing that are not this? Like, you know, things like, I don't know, understanding pure functions or mutability or other kinds of effects is probably, I think, higher priority than aliasing. Even
I
if, I
have
mean,
a
they're
lot of that
correlated.
already. I have that a lot of those already implemented.
But to
Yeah,
some
No,
extent,
the
those are
priority
saying
argument
that
doesn't
one
hold.
of the big
The priority
wins
argument doesn't
of
hold water. People use Python, so discussing whether or not if it's applicable for a 2x speed up or a 1% speed up, people use Python. Uh, if this tool is useful for someone in a particular thing, then it's worthwhile looking at. Um, if it's an interest, it's worthwhile looking at. So yes, there are other things to go in the language, but it's that's why we have many, many languages. So we can try many, many things. This could be
I,
worthwhile trying.
I definitely won't
yeah,
dispute the idea that, like, if you want to do this, like, by all means, go for it. But I think in terms of what I would prioritize, like, it seems like from what I see, you're kind of aiming at the same kind of niche as like C++ or Rust or Zig or these other like low-level systems languages that are reasonably high performance and reasonably low overhead. If you look at the current span of those, like, really not very many of them are super strict about aliasing. Really, I think maybe only Rust, and Rust even only kind of. So like, I think like the prior art and the prior user base who would have demonstrated interest in a language like this, I think there doesn't seem to be a lot of evidence that it like matters to them that much or that it matters for performance that much. Um, but like, I mean, I definitely don't want to disagree with Ben's point that like, you know, there's a million different research questions you can investigate, and like this is something that has a lot of potential where like maybe you do figure out like a really cool system for doing this that actually does get a lot of benefit, or or you could just explore like what are the actual implications of this. Certainly you can do that. I'm just kind of
yeah.
giving my sense
I
of
think
how much it
I'm the
matters.
only one that likes this idea. It's fine.
You're definitely not the only one, but like I think I tend to think it's a little bit more on the strict side than most people would want, I think.
Yeah. I'm definitely doomed to implement, or I'm definitely doomed to design languages that only I would like.
I mean, that's fine, of course.
Yeah,
Like,
yeah,
yeah.
I think one user is more users than the median, or at least the mode.
I am
I
looking
do think there's
for.
value in having different pointer types that you know something about to avoid those copies. But I haven't decided yet whether I want me to understand the distinction of this is a unique pointer versus this is an immutable pointer versus this is a only one writer pointer, but potentially many readers. Or whether I want that to be a thing that exists only in the mind of the compiler, and I, as a developer, never think about it, but the compiler's like, oh, I can tell that this is a pointer where there's only one immutable copy of it that's moving around, and all the other copies are read-only, so I can do magical things.
You know what? That all depends on whether the compiler brings performance down what you want. If you had your druthers,
Java only now is getting the concept of a non-nullable field, but the JVM has had that concept for a long time.
yeah, but I claim that Java's adding that because of people want it not for performance, but because they want to have a get a compile time error sooner and deal with it. It's like Kotlin, no fields or not or whatever. But the performance that nullable will make no difference to performance.
So you think that argument of exactly one mutable pointer for this thing can exist, and all the others are immutable. All the others are read-only.
That's a stability correctness thing, not a performance thing. It turns into performance totally, but the reason you want it, just like the null,
But
the
it's
reason
nice
you
to have
want it is
tooling that helps
correctness.
you do that.
I'm sorry, say again.
It's kind of nice to have tooling that helps you do that.
Yeah, get your bugs out so you get the code done sooner.
And you're like, hey,
If
I'm going to
it made a
stick this
giant difference
pointer.
to
If I want to
perform,
stick a read-only pointer into a hash map of a thing for which the right pointer is unique.
I'm sorry, say it again. You
There
have
are
a
times
read-only
where
pointer. You
there's
only read.
exactly one writer.
Yeah,
There is one producer that updates this value.
yeah.
Maybe this is a pointer to the queue of work that is my thread's work.
Yeah, okay. So you're talking about multi-threaded situation. I have one writer,
Like
many readers.
nobody else will read it.
Oh, we'll read
Nobody
it.
else will write to it, but other people may potentially read it.
Yes, very common. Yes. You can't express that at the Java language right now.
It's very hard to express that in most languages.
Okay.
To be like
Pony.
the ability to write this object belongs to this thread, but the ability to read it is global.
Yeah, yeah. This is like a pony is their claim to fame. But it's a
Yes,
cool
Pony is the
idea.
type system that I'm thinking of, and I'm trying to decide if understanding that can help us. So like Rust, I feel like I'm carrying annotations around in lots of places.
Hmm.
My hope is the ability to put something only at the init and be like, hey, I just told you what the type was at the init, and then it does forward flowing to everywhere else.
Hmm.
The ability to just be like, here is my writable thing, and I can say get read pointer for this object.
When you say
And
only
everything
at the
else is
init,
just forward flow and the compiler figures it out.
when you say only at the init, you mean within a local function or across the whole program? Because as soon as you go across the whole program, you're basically asking for type inferencing.
Yeah, I'm basically asking for type inferencing
Yeah,
that
because
has
I wrote
distinct
it once.
concepts like, is this a unique pointer, or is this a one writer pointer, or is this a racing pointer?
Right. I wrote it once somewhere and then I passed it along. But every pass along point, I copied the type again and again and again, every pass point where I didn't. And
And if
that
it's a
one
racing
example I
pointer, I
gave
better
one
play
is I
some kind
just
of
read
Cas
it.
or locking game. And if it's a right one writer pointer, then I don't have to.
No, no, I understand the performance. I'm saying you said I want to say it once at the init, and that immediately implies that you didn't have to write it at every function where you passed it along, every function pointer where you passed it along, or you did.
Yes.
And those are different rules. But it's also another interesting thing is if I had one and I mixed it up with a bunch of other guys who look like similar type things, but they do or they do not, uh, the
Right. Because it plays different games. If I have my one writer pointer and I pass it into a function that only needs a read pointer, I still have it. If I pass it
yeah,
into a guy who wants a right pointer,
yeah.
well, he's got it now, so I don't have it
So you have
now.
to give it up. Yeah, that sounds like a linear typing. You have a thing that is uniquely I am the one, and then I hand my oneness off to somebody else. That's linear
Right.
logic.
But most of the time, you'll never have to think about it because most functions will only take the read version.
Yeah, yeah. Well, I think
It's only if
that's
that
a
function wants
reasonable.
the mutating version that suddenly you've given it away.
You can hierarchically arrange inline classes so that the constructors scaffold an opportunity to create functions specifically to your, success in
You,
the path
you're
without changing the definition of double in the
you
case of units or
you're
scientific or
proposing
something.
to build up a structure with language constructs that exist already to support what Aaron wants, which is a totally reasonable thing that people do all the time. But the language itself doesn't guarantee that, so somebody could work around your proposed structure simply by not following the rules.
Right. The JVM supports the union type rather than the exclusive alias type of the same thing.
As soon as yeah, as soon as I say I have a foo and Aaron wants a read-only foo or read-write foo, and you say I have a foo that supports only the read and the foo version that only does the write, and somebody just cheats on it and makes one the other, and you don't have any defense because it's not a language implementation provided semantics, so I can just cast. Just like in C, I can just do a cast. So it's very helpful to be able to build such a thing and test if you're playing by the rules. And then there's a whole other step that goes that says the rules are actually completely hard enforced, and you cannot break the rules, and you get to
Well,
a new level of the
instead of
usefulness of the thing. Because
instead of
since you can't
inline
break the
class
rules, like tooling all knows, and every foreign compiler all knows, and
instead of inline class, you can just make real classes, which then gives you that exclusivity.
yeah, I have to go look at what you're proposing when you
It's a
say it.
handle. Like when you make a handle, then you can, hand off a new handle with a new part of the FSM. Um, you
What's an
know,
FSM? Finite state
finite
machine.
state machine. Yeah.
Yeah, yeah, yeah. But that's not what Aaron was asking for. He's asking for read and write permissions. I'm confused where this came from.
Where does read and write happen outside of an FSM?
Yeah, but where does FSM come from in a read and write? Like I want to have a thing that says I can read and write it, and then when I hand out to somebody else, here's your version that you can only read. And Java totally supports this in this, wrapper layers, and you can totally cheat through the wrapper layer. And if you don't cheat, it's all good. And the same with C in casting. I can cast a const pointer. I hand you a const pointer, and you can cast it away. Okay, you can. There's
Um,
nothing to do with FSM. So FSM is something else.
okay, well, with inline classes, you could put the code in a place that didn't have a reader to assume. Um,
Yeah.
that's best I could come up with.
Oh, right. And all these things have a cheat. Well, maybe you could do that in Java enough. Like I'm ignoring reflection here. If you disallow reflection in all things Java, because that's Java's cheat mode.
Kotlin has inline classes, and the JVM has inline classes that it calls value classes. Um, Kotlin adopted that, but that is it's basically a immutable single primitive constructor. I don't think you get to use an object, but I could double check. So then you have a fully differentiated class on
Oh,
top of a primitive.
I'm sorry. I got to.
Well,
Again, you
that's my
can
two
go in
cents.
either directions. Languages like Rust, I find that people say .copy all over the place, and then they're trusting the tools to eliminate a lot of the copies, which is very different from a copy on write language where I just have my thing that looks immutable, and if I'm actually doing stuff that doesn't require copying, then it just doesn't do the copy. So you can trust a
Matt
language to put
left
in the
you a
copies
link.
where it needs it, or you can trust a language to take out the copies where it doesn't need it.
Well, Matt left you a link for Swift if you want to check that out.
Yeah, Swift definitely has a lot of interesting ideas in it.
Sorry. Back. We were deciding to buy a yard scale Kerplunk game for Burning Man or not, and it's $90. And it's like, oh, come on. It's a piece of 3 foot tall piece of plastic, $90. Never mind. Completely unrelated. Fine. All right, it's quiet here. What's going on? We're all dead now. Is it time to be done?
We're compiling.
Yeah, we're all compiling things. Yeah, no, busy morning. Fine.
Did y'all see the story of Anthropic's experiment at trying to get Claude Code to write a C compiler?
Yes. That was fun reading. There's still jobs yet for compiler writers. We're not AI'd out of a job yet.
It got way further than I thought it would.
Okay. Yeah, maybe it gets there. I don't know. Then we're all out of a job. And then the AI will take off, and be Skynet, and that'll be the end.
I was having a discussion with someone at work recently about I have gotten to the pace where I totally trust my assembler. I never look at machine code. I almost entirely trust my compiler. The number of times I've compiled in my life is way larger than the number of times I've looked at the assembly that comes out of the compiler.
Right.
And even then, in a megabyte-sized program, I'm probably only godbolting one function and looking at maybe 100 assembly instructions out of millions.
Right.
Do you get to the point where the source is the prompt? And then you've got some model that turns your prompt into code and then turns the code into a machine binary. And
But I think that would basically mean that programmers would have to be good at writing specifications, and they currently really aren't. Like even if you consider things like simple undergrad first year sort algorithms, and you try to get students to formally verify them, many of them will just write the precondition that the output has to be monotonic, but many will forget that it has to be a permutation of the original input. Bam! You just got the sorting algorithm wrong. So the programmers cannot even specify such a basic concept. And then how is
yeah,
it
you
going
put them in order and it says for range length count.
Yeah. So that I think is the challenge, that even high level specifications, which is I think what most people mean when they say that the prompt will become the code. I think that means really high level specifications. But even high level specifications are really hard to get right. So you need some kind of a there's actually been some work on verifying the verifiers. So how do you know that the formally verified system specification actually covers what you want to cover? And I think we have to get better at that.
Right. But my instinct is to come at it from the other way. Formal verification still comes from the assumption of you care about all of the behavior.
Mhm.
The idea of moving up the stack is to have more and more and more of the program fall into the category of I don't care.
Yeah.
I feel like if you don't care
Like,
about all the
here are my
behavior,
actual objectives,
like
and more of what the computer, like in C code, there's very few places to say, I don't care how you accomplish this,
But
just
wouldn't
accomplish
that
this.
in practice boil down to things like sorting algorithms that sometimes work? Like they work for the common cases, but then will just suddenly stop working for the less common cases. And because we only have a statistical argument, we cannot possibly know whether they're going to be correct or not.
They'll be correlated even, so the
Yeah,
failures will all come in the same
sometimes
direction.
it sorts, sometimes it doesn't. Most of the time it sorts. Even that may be the hardest one to debug.
But the point I heard out of Aaron was, I just want the tomorrow's weather today. Statistically correctly tomorrow's weather today, and I don't care how you get there. So I don't care if the sort's almost right and fails sometimes or not.
I mean, I think
So
there's an aspect where like it's like there's applications where maybe you want like a single purpose thing that only you ever care about, where it is actually most of the work to just churn out like a script or something. But if I think of like, I don't know, any of my industry experience working in compilers, like 0% of it probably is just churning out a feature, right? It's, oh, well, we found like 1,000 crashes out of 100 million devices, and that's concerning. So figure out where in the compiler that's breaking based on some 100,000 line source that's getting miscompiled. Like once you hit like the scale where you actually have like, where you're actually good enough at actually, optimizing things, right? Like I I feel like I mean, for one, certainly right now you blow out the context window of basically any AI tool, is my understanding. Two, also like I don't know that you're necessarily very efficient at dealing with a lot of those, because like those are often less about recognizing like a particular problem and more about like trying like a huge selection of different angles and things like that. Like, or I guess like my overarching point is it's not necessarily surprising to me that AIs are kind of okay, that once they index GitHub and everyone's hobbyist C compiler, they can turn out a kind of okay hobby C compiler. But like in terms of the grand scheme of like, what is the actual work that challenges people who are working on LLVM? I don't necessarily see it scaling to that extent, because it's night and day, right? They're entirely different tasks.
But that's not what
You-
most programmers are doing. What most programmers are doing is trying to get business logic for businesses into web forms and databases.
well,
Wouldn't
so here's maybe my angle. If you are working on random business logic like that and you don't care about every ounce of your behavior, I feel like quite often what that leads to is you end up with something that looks good, and in your limited testing that you generated with your AI, it might pass everything. And then a month later, you realize, oh, actually, here's all this stuff that has been silently breaking that I didn't know about because I did not write any of my code, and I could not
like a
debug it
handle
because all of my
refunds?
debugging tools were also made by the AI, and
But I
the AI
don't
doesn't have
know
the context to figure out where that came from. So what do I
who
do?
gets what money when they ask for refund. So the Nigerian princess has been collecting all my money for refunds for things that were never bought.
Yeah.
But,
Like
but
I
then
feel like
how's it
90
different
Right.
from human programming?
I
You
mean I
Because
don't
can't
think
earlier
an
it's
because you care
average
about them.
programmer, like yeah, they don't write perfect code. They write buggy things, and they discover problems later, maybe from
Okay.
And we
production
fix them
incidents.
when
I
we
think the
find
big
them.
So
thing
And
is
we
like
fix
if
them. Yeah.
you look at what people are giving AI credit for, it's often these feats of, oh, well, it generated this very impressive program. And then if you subject it to scrutiny, it's usually not that impressive. But then also like that type of scrutiny is really 95% of what a programmer's job is, right? Like it's not necessarily turn out the feature. Maybe for some people it is. I have not worked in these types of jobs. I'm a compiler engineer. I usually work on like the big infrastructure stuff. But like, you know, I feel like even at just business scale, a lot of your issues are going to be, oh, well, something broke, or we have this weird interaction with the system, and I've got this big complex thing. I need to like talk to a bunch of people to figure stuff out. And an AI can kind of do that, but like I don't know. Like I feel like the context window mismatch is maybe one of the bigger things. It's
Right.
easier, it's still easier, a lot easier for a human to understand a complex system and figure out what angles it needs to like investigate versus like an AI that can handle, I don't know, like 20,000 lines of code and only kind of okay.
So
And
the
then it kind of breaks
place where
down.
my mind goes with this for the don't care is the experience we've had comparing Fortran to SQL. I could churn through a giant pile of data by writing a SQL query, and I can churn through a giant pile of data by writing some Fortran code. There's been very few moments when Fortran code magically got 50 times faster. But we have moments like the Vertica moment when someone says, oh, we can replace these SQL databases from row stores to column stores and get this 50x speed up that basically every SQL program on the planet suddenly got a 50x speed up in 2 years.
Yeah.
What is it about SQL that enabled me to not say things I didn't care about that Fortran didn't? That in Fortran I end up being much more specific about details. And like
Rotate.
as far as Turing and Church cares,
Yeah.
yeah, you can optimize the Fortran code and do something like a Vertica, but for some reason SQL did better at that. The thing that I'm increasingly curious about as we move into this world where these, what should the prompt look like? I don't think the prompt should necessarily look like natural language English text specifications like is in the C++ specification. But maybe we need to be thinking about our languages differently and say, how do we design our languages so that you can really say the least so that all of the tooling under you has the most flexibility to make big changes? So we do get these spontaneous, someone had a good idea, like a column store that suddenly sped up everything hugely.
So
I mean, I
that's
think
not another
this is the
clarification. But you got very important point, I think, about this Fortran, because I think right now where we are with agents is that they are very good at generating today's Fortran, which is Python. That's possibly the biggest problem is that right now, if you can write the prompt to do application X, it's gonna generate really boilerplate Python code for application X. You're gonna commit that to GitHub, and you are stuck with legacy that's never going to be optimized, just like in that story where the sequel can suddenly be optimized 50x. Because in a sense, those AI agents, even though they are given high-level prompts, they generate very low-level code. I mean, Python is almost like machine code for those people who use agent programming. They don't really look into this generated Python. They don't see if the high-level libraries were used or maybe the wheels were reinvented from the scratch poorly. And that's pretty much an incomprehensible, unmaintainable, unoptimizable slope right now. That may be the challenge.
Yeah. Hey, Levo, you wanted to say something?
Just not
Yeah.
not as high level as it seems.
Before we get into the topic change of why SQL can be optimized 50x, this is funny. I heard that I don't know if this is true, but I heard that the GitHub CEO or the ex-CEO is making GitHub for AI agents, and it records all your prompts as well. I thought that was just ridiculous and kind of funny, but forget about that. The thing is, if you have LLVM or an LLM as a compiler, wouldn't changing the implementation of one function affect the implementation of another? Because I don't want to deal with that.
I think if you have the LLM as the compiler, you're not thinking of functions at all. The LLM is solving the problem, and then how it does it, you shouldn't be looking at it.
Well, no, I mean, if a function is working and then changing another function breaks the unrelated function, then that would just be
That's not the
cursed.
LLM though. This is what I'm saying. If the LLM is doing solving the problem, let it solve the problem, and then see, and then somehow figure out how you're going to test that it actually solved the problem.
Oh, so we're talking about LLMs writing code, not LLMs generating code, because I thought it was we were talking about
But
generating
writing code and generating code, yeah.
I think that hits the point that we just don't need just a good input language for the LLMs,
Yeah.
like the specification. We also need a good output language for the LLMs. So what they can generate can actually not suffer from those problems that one function changes and then the application specification is broken and then the other function is broken again. And I don't think we have very good output languages right now for this either.
Well,
I mean, I think
I would
like
certainly claim that if an LLM is writing one of your functions and it's going to break another function, that you're at the wrong scope. The LLM should be handling both of those and maybe make one function out of it, or maybe make 1,000, and you don't care and you shouldn't look. And he solves it or he doesn't. But if he's solving here and you have this piece, but the AI is not seeing this piece, he's only seeing this piece, I would totally expect that to bust.
It's
Yeah.
just the same problem with human programmers. You have to make sure the LLMs don't make use of the Hiram's law. That if they can exploit some incidental design of the system, they will exploit. They will reward hack as good as humans reward hack. And I think that right now only those formally verified languages are capable of isolating module boundaries like this, but they are not universally adopted, to say the least.
I'm thinking of outsourcing to bad Indian programmers of, solve this piece of it and I'll solve that piece. And the solutions are not compatible. And I've been there and it doesn't work.
Yeah, AIs just give the worst person in your organization, employ 1,000 of them, let them go ham at the code base and see where you get to. LLMs, they may get better. I don't know what the scaling is disputed. There's lots of people saying it's going to hit a wall, etc. But if it gets past and it is actually better than the average programmer, then it'll be useful, because then all these problems disappear. Because through that
You have all these
definition you've
unemployed
said,
programmers.
they're better than an existing program.
And they need to go
But
into the
otherwise,
construction industry building nuclear power plants for the AIs.
yeah. Well, at the moment, everything I've seen, I look at it and go, this is what a junior programmer just out of high school would
Right.
write.
Yes.
And it's just, yeah, look, you don't understand program structure. You don't understand any
But
of
they
that.
do it with such enthusiasm.
So does the kid out of high school. Like, they're just there to help. Oh, I did this. Yeah, you just broke everything. Oh, I'll fix it. It's like, it's okay, not out of high school. Have you ever had a 4-year-old in your house?
I have. Yes.
Yes.
And I've had them come help fix. Yes.
It's that enthusiasm that is yeah.
Yeah. Yep.
But
Yep.
so no, if they do get better than the average programmer, then by definition, it's not a problem. But at the moment, it is. They're really, really, really bad juniors.
I think there's kind of two angles to this, and I think it's tempting to look at this from a PL perspective, and like the argument that that a LLM will eventually be this like new high level interface to code. It's very tempting. I mean, that's the same argument as for using high level languages. I mean, that's why the SQL argument is
I think
compelling.
it's
You
very
use a
tempting
high
for
level
people
language.
outside the programming world. And for people inside, it's a little spooky and a little tempting and a little of this, a little of that.
Well, and
Yeah.
I think the PL argument is kind of a category error, because the reason that your high level language like SQL is able to get these kinds of speed ups and you're able to write code more effectively at this high level that doesn't sacrifice performance is because you're at a higher level that is more rigorously specifying its high level functionality such that that can be faithfully implemented at at a lower level without losing any of that functionality, right? Like
Right.
you don't care about exactly how the SQL is implemented, but you really, really, really care that the SQL is implemented correctly.
Yeah.
And that is where, I mean, LLMs architecturally, any AI that is probabilistic is going to be more fallible than that. You are sacrificing the correctness of your probably rigorously specified SQL and Fortran. I mean, I don't know the exact status of those. There's dialects or whatever, but they're better
Yeah.
specified than whatever like Claude code
mean,
spits out, right?
That's a
Maybe.
also
So there's very different games.
look. I
So
don't
Cliff
just
has his
quickly.
Sea of Nodes compiler, and it's got a bunch of peepholes that it can apply. And he's got a giant pile of heuristics that say which peephole do I apply, at which times, in which orders, and vague priorities there. If you take an LLM and say, here is a set of transforms that you are allowed to make to my Sea of Nodes or to my AST that I promise you are not changing the semantics of the program. And now the challenge I've given you is apply the peepholes in some order to try to get to a really good state. And I give you a reasonably good objective function like runtime or binary size.
I moved past that. I up leveled. I claim that under Simple's model and AA's model, the rules are you can apply them in any order, and due to the Church-Rosser effect, one step dishwasher. You will arrive at the same answer no matter what you do. So there's no choices here. There's no heuristics.
There are
Just apply
definitely
the
some
same answer.
there's definitely some spots in a compiler, but I think this is a narrower feature, and I do actually think this is a legitimate use of machine learning. But like it's very narrow. Like there's only so many parts of a compiler where you actually do have these kinds of ordering situations. It's only safe to like swap around and experiment with this order if all of the passes can be applied safely in any order, right? Like you would not want to hand a bunch of phases that have interdependencies that can go wrong if they like or like maybe you hook some verification up or something, but like you would not want to hand an AI just like, here's my stuff, please do it. Oh, but you can actually fuck it up because that's bad. Like you're gonna break your program. If you put it in a situation where it can't miscompile, though, I think there's narrower applications where AI can and has been applied. Like something like an inlining heuristic is like a famous, straightforward example, right? Like it's a very easy thing to train for. I mean, asterisk is a complicated thing, but it's not crazy to imagine how you do this. And compilers have done this, and you can get, pretty good heuristic effects where like you actually do make a better heuristic because that's the thing that AIs are really good at is optimizing some heuristic. I think that really breaks down as soon as you have a fallibility case where you have these things that you can and often, can pretty rigorously specify like, well, all these things are not going to break my code. As soon as you hand this responsibility of making sure you don't miscompile the code to an AI, I think you've given up a lot. Like any miscompile, even if it's super rare, is very likely to get hit somewhere in practice. And especially if it's hit in like vanishingly rare circumstances, that really just means it's going to be a lot harder to find and a lot harder to deal with. Um,
Humans write those
it-
bugs too, though.
oh
Yeah,
yeah,
that
well, so I
exists.
think I
That's
think
current state.
so. I think this is why if we're talking about AI adoption, I I think it's a category error to think of this as like a new level of like high level languages. I think it is more correct to think about it as a basically purely economic question. If I am running a company and I have X dollars and I am okay with X amount of bugs, then does the AI manage to do this successfully in all of the things that a normal developer will do? And, is it more bugs? Is it maybe it's a certain amount more bugs for a certain amount less money? And that's like, that's an economic question. But I think it's less grandiose than a lot of people act like it is, right? Like I think a lot of these things where it's like this transformative thing for PL, I don't know if I buy it. If it's, is it a transformative thing for the economy? I guess we'll see. But that's, kind of a different thing.
I have only one AI success story if you guys want to hear it.
Sure.
I'm assuming that more will come, but yeah.
So was using a third-party library, like I had to use it, and it was completely undocumented. And I couldn't see the source code either. So all I had was a function signature, and I had no idea what the parameters do because they were very generic parameters. For some reason, when I asked the LLM, I guess because I looked at GitHub and other people figured it out or knew the internals of it, it was able to generate my example code solving my question because it was able to see it had an idea of what the documentation should look like if it existed. So it
I
was able
wouldn't I
to
wouldn't go
generate
to these
something that was
because
usable.
it
Huh?
solved my problem. Okay, good. Why?
Yeah.
How? No, 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 no.
Yeah.
Yeah.
I
So
used to get
it,
stuck and Google it and then click on the Stack Overflow link and then copy code. And now the AI gets stuck and Googles it and clicks on
Clicks
Stack
on this. Yeah,
Overflow and
exactly.
copies the code.
Uh-huh.
yeah. So for undocumented code, it might be useful. Yeah.
Uh-oh. Here's Ben's got a psychotherapy services AI generated website. I shouldn't click
Yeah,
this link.
yeah. No,
I'm
yeah,
not I'm
again,
not
it's
sharing.
yeah, don't share it. It's just it is a website that is this is a actual service provider, been around very long time, and they went, oh, look, AI, and this is the result.
Oh my God. It's it's kind of entertainingly, it's very flashy and bright and full of fake pictures that are kind of sort of related to what the words say.
But
I,
not in the
kind,
it's in an it's both it's so bad.
yeah,
This
no,
is my
no, 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 no,
experience with
no.
AI.
It gives me absolutely
They-
no warm fuzzies for medical services. No, I'm not.
yeah, yeah,
Do you see the
yeah.
Men's Health picture? Don't look. Sorry, never mind. It was
Yes,
clearly a
yes.
woman's
That was my
hip
favorite.
region done mechanically as a Men's Health.
Yes.
But you
I'm
do see
done.
those funny moments where you're like, the AI realizes that some particular function isn't needed anymore. So it changes it to just say pass and have as the description of the function, this is a no-op function that does nothing, but is still left there and is still being called. You're like,
Uh, right. Yes. Okay. There's something yet to be done here with this AI. By default,
um,
get rid of
but yeah, it definitely
the
makes me
code
think
readable
about,
something. All right. All right.
like a famous example of that is types. As we get better at type inference, it allows me to just not say types when I don't care
When you don't care. Yeah.
and let Henry Milner pick the type for me
Yeah.
because it knows what the type needs to be at this location.
Yes.
And if it needs to be an int32, that's fine. And if it needs to be an int64, that's fine because there are constraints somewhere that make this true.
Yeah.
Like the idea of being able to, I guess I would phrase it this way. How do we design our programming languages so that we can avoid putting in constraints that we don't care about?
Yes.
And
That's
why did SQL do it better than Fortran?
the
Like, what
major
was the
difference between
difference
for I
there?
equals 0, I less than n, I plus plus, and map over an array is that one gives you
Uh,
an order, forces an order, and one just says, I am going to visit everybody and do something.
the biggest difference is SQL Server got a 50x speed up because it was just 50x slower. There is a reason why no one did the million row challenge in SQL Server. Just saying that, oh, look, we've got Python. Python is now 30 times faster. How did we get these speed ups? Well, we just stopped doing the dumb stuff.
Yeah, we first started by going 30x
So your argument
slower.
is you think
Yeah.
Fortran didn't get these giant speed ups because Fortran was already faster for data science than SQL was.
Well, it also didn't last as long.
It didn't last.
Sort of.
Someone did use
Well,
Oracle for the 1 billion row challenge. It had like several iterations on that too.
How fast they end up going? I'm
They have
curious.
at the end
okay.
of the code. Fraction of a second.
But like again, if someone told me, hey, this new SQL thing
Oh, someone's
is running on
pre-computing it.
40,000
That's right.
cores and getting a huge speed up. That's easy
I mean,
for
I
me to
think
believe. If someone said, I'm going to rewrite your Java code for 40,000 cores and get a huge speed up, that I'd be suspicious of.
I think the critical advance is like if you have something like type inference or you have a higher level language like SQL where you are more polymorphic over your backend, I think the critical thing is that all that information about how to solve the program is still there. Like you are exploiting the fact that you were maybe writing over specific programs, but you are still like you are given a mechanism for expressing exactly precisely the exact same functionality, just omitting the things that were kind of redundant to start with. I think type inference is a very good narrow example of this because type inference typically, especially if you're in like an ML, is exactly equivalent to like type checking the code, right? Like if you have a reasonably narrow enough type inference system, like you have in like OCaml or SML or something, then inferring the types is exactly just what's there. Like you could have done that from the start. It's just, it's somewhat more algorithmically complicated, and so people didn't. But once you have that type inference, like you're still not losing anything, and you're still really specifying all of your types. You're just doing it in a slightly more implicit way, in the sense that like adding two numbers still has a very strong static type annotation that is never violated, and there's no chance about exactly what that's expressing. Uh, it's just, you no longer have to actually mechanically write like colon int or something after both operands anymore because, the compiler is smart enough and it can do this little algorithm. Um, this is, I think, and this has always been and it will always remain a very compelling area for PL designers because there's doubtless like so many things that are awkward and hard to express right now, but you could still very strictly specify in a well-defined language and immediately get a lot more like throughput. Like it's easier to write database operations in SQL. It's easier to write a GPU kernel in CUDA rather than having to write all of the like underlying VM that's on the chip. So like, I like this is a compelling argument. I really don't think LLMs fit into this because they are information destroyers. They're lossy. They're lossy compression. Like you have a specification, you want something to do exactly what that specification says. You are immediately losing a lot of the value of having that specification if you throw it into a oracle that is correct 99% of the time. Because then if you run that thing 100 million times, maybe you find that 1% case where like, oh, all of a sudden like there's a giant security bug and I'm immediately destroyed. Like I, I think that like even with an extremely high success rate, these things, even if they are on their surface very simplifying, are like massively more complicating in terms of the actual effort needed to develop software. At least for, I don't know, maybe certain clades of software. Like if you have software that correctness really doesn't matter and you don't care about security for some reason, then maybe it's fine. But like
Recommendation systems.
I would like to make the argument that most of the time, you should probably care about the performance and correctness and security of your code. I mean, like, what are we doing here? Like, there's maybe some economic places where you can skirt by without doing that, but like, uh, you know, we should strive to have better things that work and don't leak everyone's data and cause your grandma to lose her 401k. Like, I mean, come on. So yeah, I don't know. I think like this is
We're
this is a super compelling angle, and I think like I could see some future for machine learning in certain parts of things. Like I said, I think in narrow domains where you have a heuristic that is infallible, like inlining heuristics or something, or maybe pass ordering or other things that are maybe a little bit probabilistic. Like you could maybe have a heuristic for like exactly what kind of scheduling register allocation
all
mix you
right.
have or
But as
something.
a potential devil advocate, we do see some success in the lean prover community in mathematicians using AI for very exact problems where you do have to be exactly correct. And I don't think Terence Tao, I would say he knows what he's doing in mathematics. So maybe I wouldn't dismiss the argument just because the system is probabilistic. It doesn't mean you cannot average out the output to get the deterministic result. That's well known. So I wouldn't really dismiss this on the correctness grounds. If it can be used successfully in mathematics, in formalizing it in lean, this
I
could
think the
transfer
big thing,
science
like
too.
The
I think my counter
probabilistic
argument would
argument
be
only works in the absolute extreme. So you have to generate billions and billions to get one deterministic result.
What do we have? Well,
If
that's
maths
the
was the answer,
but then it's not
we could do weather.
Well, I think we already built reliable enough systems with non-deterministic actors, humans. And I agree with Matt. I think they are like LLMs are already pretty good, and I think we can make it work. Yeah, we'll need to put some guardrails and fences everywhere, but I think you can assemble a reliable system even if individual pieces are not necessarily reliable and always predictable.
I mean, so I think my reaction to that, like I think maybe to respond to the math thing, I think that's probably just seeing what is maybe obviously true, which is we're going to see the success of this really vary based on domain. Like I can believe that something where you're using this in lean or something, probably your code volume is not measured in the millions of lines. And once you find something that does work, you can probably pretty easily validate it and understand, okay, yeah, here was something that, with my actual formal prover, I could say, yeah, this is a valid proof for my thing. And I was able to use the LLM to generate some different approaches and maybe help me trawl through ideas a little faster. That's an area where I can see the application there. But I feel like for a lot of software, like really the maintenance and scale are kind of your bottlenecks. Like a lot of software development is, I have this gigantic, gigantic code base and this extremely complex system. Uh, and the maintenance over years and years of finding all these little holes in there is like most of what my engineers spend their time doing. At least this has been my experience. And, again, I mostly work in like infrastructure, but like I think, these kinds of infrastructural things, like I have a hard time seeing AI being that useful there. But like I will gladly concede that, well, maybe not gladly, but like I will concede that certainly, depending on domain, you're going to see dramatically different results. And in stuff where you mostly are just trying to synthesize something that you can verify, sure, it's viable there. I think the open question also is just, well, how good do we actually think LLMs are, and are they going to get better? like how much better would they have to be for the economics to make sense? And I don't know. I don't know if anyone's figured that one out. It
I
seems a
haven't
little irrational the amount that people are already buying
I
into them
haven't
being really good right now, but
I
you know,
haven't
maybe they
seen
get 10
them
times better.
do
Well, yeah,
architectural. I've seen them find bugs in an existing architecture. I haven't seen them do architectural work to clean things up to make it less likely to have bugs. Yeah.
That's
Let
probably
me
the
actually
biggest
break
weakness.
your general. Levo, is it okay if I comment your chat into the doc? I think that's a great comment.
Yeah, go ahead.
Okay. Um, yeah, let's wrap it up. I think we've gone round and round and agreed that we're in an interesting time with AI and it's moving fast and things are changing and we should keep an eye on, watch what's going on, but it's not challenging anybody here for what you're doing anytime soon. But it's worth watching.
And we need to get better at writing down what our constraints are.
Yeah. I
Yeah,
on
this
my
key
giant
word.
pile of to-do list is I have a AI, turn on AI and go do something useful with it. I have a for work paid link now. I need to go make it happen. See that it
But it's definitely not
costs
at a
me more
place
than
where
I
we
can
could
fix
listen to
myself.
all of our YouTube videos and then go implement AA.
Yeah, yes. Maybe. How fast can an AI walk through a YouTube video? Faster than real time? Probably. How much? I don't know. I have no idea.
I have already seen a pretty good use of someone using this basically go through the transcript of a YouTube video and then summarize the transcript so that you don't have to watch the YouTube video. It's a one way to save time.
Yeah. This reminds me of that, joke of, well, I'll just fill out this form, I ask an AI to finish it, and the next guy who reads it says, well, I'll just take this giant blob of text I got and get the AI to summarize it. So no, just write the one-liner you needed, and I'll just read the one-liner, and we'll walk
Yeah.
away.
I turned 3 bullet points into a 3-page essay. They turned a 3-page essay into 3 bullet points.
Yeah, right, exactly. Yeah. All right. Minus a little fuzzy in the translation. What got lost? Uh-huh. Okay. I'm going to call it, and then, that was entertaining as usual. So next week. All right,
See
bye-bye.
ya.